square root value. So in here, starting with finding the domain of the square root function. Now we have learned that the domain of the square root function is taking the expression inside, make it greater than or equal 0. So x squared plus 1 greater than or equal 0. That will give me x squared greater than or equal minus 1, then square root of both sides. So in here there is no square root of negative value. So in here I would say basically the domain, it will be from minus infinity to infinity, which is r. Okay, so now directly straightforward. So find the derivative of what inside the root, which is 2x over 2 multiplied by the same root, x squared plus 1. 2 with 2 eliminated. So in here make the derivative equal to 0. The zeros, x equal to 0, which is the numerator. The denominator, the undefined value, you have to make x squared plus 1 equal to 0. So that will give me again minus 1, then square root of minus 1, which is undefined value. So in here, x equal to 0. And is it included? Yes, it's included. So this is my critical number. So directly I can find the number line test. So I'll go ahead with this color. So that's it. That's it. This is the 0. Then after that, I'll find the signs. So after the 0, if we substitute any value, it will be positive. If you would like to do this, you can substitute directly in here in this function. Okay, so it will be positive value, which is x over this value, it will be positive all the time. Okay, now before the 0, which is negative 1, for example, it will be negative over here. So this is downward, upward. So this is the function decreasing from minus infinity to 0 and increasing from 0 to infinity. Okay, now moving forward, this is the critical point actually, which is 0. That's it, 0 and f of 0. So you can substitute directly in this square root of 0 squared plus 1, which is square root of 1, which is equal to 1. This is my critical point. Okay, now moving to the second derivative. Okay, so the second derivative, this is equal to what? The denominator, so this is square root of x squared plus 1 multiplied by the derivative of the numerator, which is 1, minus the numerator multiplied by the derivative of the denominator. Okay, wait. So where is this? So the derivative of the denominator, which is the derivative of square root of x squared. The derivative for this is 2x over 2 square root of x squared plus 1. So 2 eliminated. So I will put these values over here. So multiplied by x over square root of x squared plus 1. Okay, over the denominator square. So this is x squared plus 1 because the square root, it will be eliminated with the square. So now we have square root of x squared plus 1 over 1 minus x multiplied by x, which is x squared, over square root of x squared plus 1. We solved a question like this before actually. So this is divided by x squared plus 1. So now we can make the denominators the same. This by this minus this by this, because we have minus over here, multiply or divided by this by this. Okay, so this is equal to square root multiplied by square root. We said it will be the same since we have the same expression inside, so it will be the same expression only, plus 1. Okay, minus x squared multiplied by 1, which is x squared, over. Now we have in the denominator square root of x squared plus 1 multiplied by 1, which is the same. Now that's it, I can write it, x squared plus 1 over all over x squared plus 1. So we can simplify it more. We can write it as x squared minus x squared eliminated. So I have 1 over. We can write these together. So we can raise this upward. So in here it will be x squared plus 1 multiplied by square root of x squared plus 1. So that's it. Then let's make this equal to 0. From the numerator, 1 equal to 0, which is impossible. So this is going to be rejected. From the denominator, both of them, they will be x squared plus 1 equals 0, and that will give me nothing because I have square root of minus 1. So now I have no values actually. So in here directly for substituting in the number line, so that's it. I have no values at all. So in here I'll substitute any value you would like to substitute. Let's say it's minus 1. Minus 1 in here it will be positive, and in here it will be positive, so it's positive all over the interval from minus infinity to infinity, which means it's concave up. So in here I would write that my function is concave up from minus infinity to infinity. Okay, which means that of course in here there is no inflection points, no inflection points. Okay, so directly I go ahead and start graphing. So let's go ahead and see how we can graph this. So let's see, that's it, the same thing. Is everything over here. Yes. Don't forget that we have to graph the mixed number line. So the mixed number line, we have only one value from the first derivative, which is 0. Okay, now we have from the first derivative we have negative positive, so this is negative positive, and concave from the second derivative, concave up or all over the interval, so concave up, concave up. Okay, so now which means over here I have decreasing, okay, and concave up, or sorry, concave, yes, concave up and decreasing, so I will take this part, and concave up and increasing, so I will take this part. Okay, so let's find x and y intercepts. So x intercept, this is at x at y equal to 0. So at y equal to 0 equal to square root of x squared plus 1. Okay, this is going to give me x squared equal to minus 1, where is undefined value. But what about y-intercept? At x equal to 0, so we have to substitute this, so y is equal to square root of 0 plus 1, which is square root of 1, which is equal to 1. So I have 0 and 1 as y-intercept. So now let's graph it directly. So I have 0 and 1. This is my point. Actually, this is also my critical point. Okay, now before the 0, I have this part. Okay. And after the 0, we have the second part. So yes. Done. That's it. This is the graph of the square root function for this question. So next we will solve another, or the last question on graphing, which is included by exponential function. So we will see that then inshallah.